Three-phase power measurement. Consider a three-phase, three-wire system with output terminals R, Y and B. Let us connect three loads of impedance Z in star configuration to these output terminals. All the loads are the same and hence this is a balanced load. In a three-phase system, the power is equal to the sum of powers of individual loads. Since the load is connected in star, we have a neutral point common to all loads. For power calculation, we measure the voltages across each load with respect to this neutral point. Total three-phase power consumed by the load P three-phase is equal to PZ1 plus PZ2 plus PZ3. Since the load is a balanced load, they are all consume the same power. This power is the product of the phase voltage across the load and the phase current through the load and the power factor of the load. That is, P phase is equal to V phase into I phase into cos phi. Thus, this is the per phase power of the load P phase. Therefore, the three-phase power can be written as P three-phase is equal to 3 into P phase. Therefore, we can say that the three-phase power is equal to 3 times that of the per-phase power. We can expand this equation with the per-phase voltage and current as P three-phase is equal to 3 into V phase into I phase into cos phi. To calculate the three-phase power using this equation, we need to measure the phase voltage of the load. For that, we must have access to the internal neutral point. In some situation, this neutral point may not be available externally. So, we need to convert the power equation in terms of the line values. For a star connected system, the line voltage is root 3 times the phase voltage. That is, VL is equal to root 3 V phase or V phase is equal to VL by root 3. The line current is the same as the phase current. That is, I phase is equal to IL. Substituting for the phase values in the three-phase power equation, we get P three-phase is equal to 3 into VL by root 3 into IL into cos phi, which is equal to root 3 VL IL cos phi. This is the equation for power in a balanced three-phase system. For AC power measurements, we have an instrument called wattmeter. There are two types of wattmeters, single-phase wattmeter and three-phase wattmeter. Three-phase power can be measured using three-phase wattmeters as well as single-phase wattmeters. We can measure the power in a three-phase circuit using two single-phase wattmeters. Here we have two wattmeters, W1 and W2. A wattmeter consists of two coils, a current coil and a voltage or pressure coil. The current coil is connected in series to the load while the pressure coil is connected parallel to the supply or load. Here, we connect the two wattmeters such that the current coils of the two wattmeters are in series with two of the lines. The pressure coil of wattmeter W1 is connected to line R, which is the same line, and line B, to which no current coil is connected. The load connected here is an unbalanced load consisting of three different impedances Z1, Z2 and Z3. The phase voltages across these impedances are ERN, EYN and EBN respectively. The wattmeter reading W1 will be the product of the instantaneous line current IR and the instantaneous line voltage VRB. That is, W1 is equal to IR into VRB. The phase voltage VRB can be expressed in terms of the phase voltages ERN and EBN. That is, VRB is equal to ERN plus ENB, which is equal to ERN minus EBN. Therefore, W1 is equal to IR into ERN minus EBN. Let this be equation number 1. Similarly, we can write the equation for wattmeter W2 as W2 is equal to IY into EYN minus EBN. Let this be equation number 2. Adding equations 1 and 2, we get W1 plus W2 is equal to IR into ERN minus EBN plus IY into EYN minus EBN. Expanding, W1 plus W2 is equal to IR into ERN minus IR into EBN plus IY into EYN minus IY into EBN, which is equal to IR into ERN plus IY into EYN minus EBN into IR plus IY. Let this be equation number 3. If we apply Kirchhoff's current law at the neutral point of the load, we can write IR plus IY plus IB equal to 0. Or IY plus IR is equal to negative IB. We can substitute this relation in equation 3. So, W1 plus W2 is equal to IR into ERN plus IY into EYN minus EBN into negative IB, which is equal to IR into ERN plus IY into EYN plus IB into EBN. The right hand side of the equation is the sum of the products of the instantaneous currents and voltages of all three phases. This is the three-phase power consumed by the load. That is, W1 plus W2 is equal to P three-phase. Therefore, we can find the three-phase power of any load including unbalanced load by 2 wattmeter method. In this method, the three-phase power is equal to the sum of the wattmeter readings.